Hello everyone, welcome back to the course Information Theory and Coding. In this session, we are going to discuss about the overview of the digital communication system. So the primary block diagram of this digital communication system is a discrete information source. So this discrete information source will generate a data and it has to be transmitted from source to destination. So when you want to do the data transmission from source to destination, it is necessary for us to convert this form, the information which has been generated at the source, which should be suitable, we can so that it can be successfully transmitted from source to destinations. So in order to do that, we will be using two important coding schemes in the use of information theory and coding, and that we call it as a source encoder and the channel encoder. You can see in the source encoder, so the input to this source encoder, it is a sequence of symbols what we have been generated from the source, and the output of this source encoder is a binary input stream. So basically source encoder, it is nothing but it is a form of an entity which will convert a source symbols into binary input stream. When it is converting the source symbols into binary input stream, so the amount of information which has been carried by each symbols will be calculated. So based upon the importance of the given symbol, so different varieties of binary streams will be generated. So generally there are two types of source encoders we will be having in the form of representing in the form of length. So one we call it as a fixed source length encoder, and one more we call it as a variable length encoder. In the case of fixed fixed length encoder, so for each given symbol, equally for all the symbols, the same number of bits will be allocated when we do the conversion from symbols into binary values. But whereas in the case of variable source encoder, for each source symbols, depending upon the average amount of information which has been generated from the source, based upon that a variable length of code bits will be allocated for the source symbols. So once I have a binary input stream, then I can easily give to the modulator, where modulator will represent this binary stream of data so that it can be easily transmitted over the communication channel. But it is necessary for us to know if there is any error happens between the data transmission from source to destination, it has to be calculated or it has to be notified. In order to notify the errors which may happen during the data transmission, we are going to use one more important encoder called as a channel encoder. So what the basic job of this channel encoder is, we are going to add some redundant information to the source encoder what it has been generated from the source information, and through the use of channel encoder it is possible for us to know the errors which might be happening over the communication channel when the data transmit from source to destination. One important thing what you need to understand in the channel encoding is, so you can see the input for the channel encoder is binary stream, and the output for this channel encoder is a binary stream also. So means what, we are adding some redundant information for this binary stream also. With the use of this redundant information, it is possible for us to know the error is happened or not at the receiver end. So once the channel encoding is done, now the given binary stream will be given to the modulator. So this modulator, depending upon the type of information what we have, a modulation techniques will be chosen. So since we are talking about a digital communication system, so we have a amplitude shift keying is there, phase shift keying is there, or quadrature amplitude shift keying is there. So with the use of any one of the modulation techniques, we are going to convert these binary symbols into an electromagnetic waves. These electromagnetic waves travels over the intermediator called as a channel. So in the channel, if it is a perfect channel means, then whatever we are going to transmit from the transmitter end will be received successfully at the receiver end. But because of the non-linear characteristics in the channel, we will be having some distortion in the given channel from the transmitter end at the receiver end. So that we represent it in terms of noise. So in the information and theory encoding, so how best we are going to represent this channel in the form of mathematical form, so that I can able to successfully transmit from source to destination. It mainly depends upon how we calculate the capacity of the channel and how best we represent this noise behavior over the data transmission from source to destination plays an important role. So the first element in the receiver end is a demodulator. So this demodulator, what is this? So it will get back the original electrical signal which has been transmitted from the transmitter end. That is, it converts the electromagnetic waves into an electrical signal in the form of a binary stream. And this binary stream of data will be given to the channel decoder. So in the channel encoder, what we have done is we have added some redundant information in order to know the error in the given information channel, whereas in the case of decoder, so whatever the redundant information which has been added to the binary stream, so that will be removed in the channel decoder. And if there is an error means, then that errors will be rectified by the channel decoder. And the next step is, so the binary stream of data has to be converted back to the source symbols. So that job will be done by the source decoder. So in the source decoder and the channel decoder, the reverse operations, whatever we have done in the source encoding will be takes place. So some of the examples I have stored in the earlier classes also. So we are going to use a Huffman encoding algorithm. We are going to use a Shannon-Fano encoding algorithm as a source encoder, whereas we are going to use a linear block codes, cyclic block codes, and a convolutional block codes we are going to use as a channel encoder. So basically in this information theory encoding, we mainly focuses on this source encoder and a channel encoder. In precise, so if you want to say precise what exactly we are going to study this information theory encoding subject is, so this is the overview what you're exactly going to study in this subject. So you have a source information. So from this source information we will be converting back to a binary values through the use of encoder. From the encoder it will be given to the channel, and from the channel again it will be given to the receiver end. So we will be working on some of the algorithm in the transmitter side, and we will be working some of the algorithm on the channel side, and also we will be working some of the algorithm on the decoder side. So why channel is important? Because whatever the data we are going to transmit from source to destination end, the mediator plays an important role. If the mediator is a linear mediator means, then successfully we can have a data transmission from source to destination. So therefore the behavior of the channel or the characteristics of the channel plays an important role. So we need to know about what is the maximum capacity we can transmit from source to destination. It is necessary for us to know, so that we can at the transmitter end we will have some maximum threshold, so above which the desirable communication will not happen from a source to receiver end.